All right, in this video, I'm going to do a complete review of grade 11 functions. There's a lot of questions in this review, about 50 questions or more, and I'm going to go through them extremely quickly. If I make any mistakes, let me know in the chat because I'm not going to double check these questions. I'm going to try and complete the entire review in 2 hours or under. And this is not meant to teach you the entire course. It's just meant to be a review for your final exam. So let's get started. Question number one, use the graph to answer the following questions. Let's list which graphs above are graphs of functions and which are not. So we use our vertical line test over here. We know that B and C will pass the vertical line test because it goes through only one point everywhere. So A is not a function, and B and C are functions. And then how could I tell that? I was using the vertical line test. And then for graph B, f of y equals f of x, what is the value of f of 3? So graph B is this one here. F of 3 is an x value of 3. At the x value of 3, my y value is 1 for graph B. So f of 3 is 1. Question number two, state the domain and range for each relation. Determine if they're functions. So quadratic relation goes to the left and right forever. So domain is just x as an element of all real numbers. My range, my minimum value here is -1. So y is an element of all real numbers such that y has to be greater than or equal to -1. And all quadratic relations are functions. So yes, it is a function. For B, it's a sideway parabola. My maximum x value here is 3, so my domain is x is an element of all real numbers such that x is less than equal to 3. My range, it goes up and down forever, so y is an element of all real numbers, no restrictions there. And this fails the vertical line test, so not a function. And then third one here is my reciprocal function. My domain is just x as an element of all real numbers such that x does not equal to my vertical asymptote, which is -4. My range is y is an element of all real numbers such that y does not equal to my horizontal asymptote, which is a 0 in this case. And is this a relation of function? Yes, because 1 over x functions are always functions as well. Part D, we have individual points over here. So my domain is just the x values. I won't write xer because it's individual points. So -6, -5, -4, -3. My range is just my y values, which is just 2. Do not repeat any values. And is this relation a function? All the x values are unique. So yes, it is a function. If I had repeating x values, it would not be a function. Question three, just function notation. They're giving us f of pi, so I'm replacing x with 5. And then I'm just going to type this all in my calculator because it's going to save me a bit of time and also prevent any silly mistakes as long as you type it in correctly. So I get -44 for the first part. And just get +6 for this second one. And for the third one, I will get 39/8. Fourth question, determine the vertex of the quadratic function by completing the square. Verify your answer using partial factoring. I'm not going to verify my answer with partial factoring just because we don't learn that in this course. So I'm just going to do completing the square and teach completing the square over here. Now, you can always use x equals -b over 2a if your school does not require you to do completing the square and then sub in the x solution back in the original equation to find the y value. But I'm going to stick with completing the square for this video. So first things first, for completing the square, I will write down my equation. Then I will bracket my first two terms, and then I'm going to common factor out an a value if it exists, but the a value does not exist, so nothing to common factor out there. Then I'm going to take this value here, divide it by 2 and square it. That's just 2 square, which is 4. So that's my magic number. I'm going to add and subtract the magic number inside the bracket. Then I'm going to take the negative number out and multiply it with what's in the front. In this case, it's just a 1 because I did not have an a value in this question. And then last step, I'm going to perfect square the bracket. So it's just x plus 2 squared. And I'm going to combine like terms on the outside, minus 3. So this is a positive equation. If it's a positive quadratic equation, it's going to be a minimum because it opens up. The x value is -2 and the y value is -3. Next question here, again, completing the square. So same steps, just slightly harder. Start by writing down the equation. I'll bracket my first two terms, and then I will common factor out just my a value, which is -2, left with x squared minus 6x plus 7. I'll find my magic number, which is -6 divided by 2 squared. That's just 3 squared, which is 9. So I'm going to add and subtract 9 inside the bracket. Then I'm going to take out the negative number and multiply it with the front. So -9 times -2 is plus 18. And last step, I will perfect square the bracket. So I'll just get x minus 3 squared, and then I'll combine like terms. So that's plus 25. This is a negative quadratic equation, so it's going to be a maximum. And the x value of the vertex is positive 3, y value is 25. Let's try the next example here. Again, exact same idea, just slightly harder because we have a fraction as the a value now, but same exact steps. Bracket the first two terms, common factor out the -1/2, and I'll be left with x squared. -4x divided by -1/2 is plus 8x. So it's just testing whether you know how to do calculations with fractions or not. Next, I'll do my magic number, which is 8 divided by 2 square, which is 4 square, which is 16. So x squared plus 8x plus 16 minus 16 minus 3. I'll take out my negative number from inside the bracket. -16 times -1/2 is positive 8. And then I will perfect square the bracket, which is just x plus 4 squared, and combine those, which is 5. Again, this is a negative equation, which means we're going to have a max. The x value is -4, and the y value is 5. All right, next question we have here is a word problem. It's a revenue question, and it's a quadratic equation as well. So we know that revenue, whenever we have a revenue question, we're doing price times demand. And this is going to be in factored form anytime it's for a quadratic equation. So my starting price is 31.25. And the price decreases, so minus 1.25 per person. So 1.25 x. And then my demand is, I start with 104 people, and it goes up by 8. So 104 plus 8x. So that's my price equation. That's my demand equation. If I multiply them together, I get my revenue equation. I need to find how many tickets need to be sold to maximize the donation. So to maximize, I'm going to just, there's multiple ways to do this, but I'm just going to multiply it all out, turn it into standard form, and find the vertex that way. So let me FOIL out these two brackets. I'll get 3250 plus 250x minus 130x minus 10x square, and then I'll just combine my like terms. So these two are like terms, so plus 120x plus 3250. And then to find the x value of the vertex, I'll just do negative b divided by 2a. That's the quicker way to do it. So it's just negative 120 divided by 2 times negative 10, which is negative 120 over negative 20, which is positive 6. Remember, x represents the number of price changes in these types of revenue questions always. So I'm going to have 6 price changes. Basically, the price will decrease $1.25 6 times. So how many tickets need to be sold? I'm going to sub that in my demand equation, which is 104 plus 8 times x, which is 104 plus 8 times, oops, I'll use a bracket, 6, which is 152 tickets need to be sold to maximize the donation. What's the price of each ticket? I'll just sub that into my price equation over here. So price equals 31.25 minus 1.25x, which is 31.25 minus 1.25 times 6, which is just $23.75. And then to find the actual maximum donation, I can just multiply price times number of tickets, and that will give me the maximum donation, which in this case is $3,610. All right, eighth question, simplifying radicals. So to simplify radicals, we need to basically divide them by square rootable numbers like 4, 9, 16, 25, and so on, and then take out the square rootable numbers. So for 54, I know that I can turn that into 9 times 6, and then the square root of 9 is just 3. So my final answer is 3 root 6. For 84, I know I can turn this into 4 times 21, and then square root of 4 is 2, so just 2 root 21. 21 cannot be simplified any further because it can't be divided by any of these square rootable numbers. Over here, I'm just multiplying. 2 times 7 is 14 root 3. Can't be simplified any further. Over here, I'm doing negative 3 times 5 is negative 15, and then root 3 times root 2 is root 6. Over here, I'm simplifying each one. So 5 root 12 is 4 times 3 minus 2. 48, you can do it in 1 step or 2 steps. If you're doing it in 1 step, it's just 16 times 3. But if you used 4 times 12, you would have to simplify further later on. And here, 75 is just 25 times 3. And then I can simplify this. So root of 4 is 2. 2 times 5 is 10 root 3. Over here, root of 16 is 4. So minus 4 times 2 is 8 root 3. And then here, 7 times 5, because the root of 25 is 5. That's minus 35 root 3. Now you can just combine these because they're all like terms. 10 minus 8 is negative 2. No, positive 2. Positive 2 minus 35 is negative 33 root 3. Let's do the same thing for this one over here. 12 can be simplified to 4 times 3. 20 can be simplified to 4 times 5. 27 is 9 times 3, and 45 is 9 times 5. I'll take all the square rootable numbers outside. So root of 4 is 2. 2 times 2 is 4. 4 times 2 is 8. 3 times 3 is 9. And 5 times 3 is 15. And then I'll combine like terms. So 4 root 3 minus 9 root 3 is negative 5 root 3. 8 root 5 minus 15 root 5 is negative 7 root 5. Some more square root questions. So let's start with G over here. I'm going to multiply these. So I have 6 times 3 is 18. Root 6 times root 2 is 12. 6 times negative 4, negative 24. 6 times 3, so that's root 18. I can actually simplify the roots in this one. So I can turn that into 4 times 3. Over here, I can turn this into 9 times 2. And then root of 4 is 2, so 18 times 2 is 36. Root of 9 is 3. 24 times 3 is 72. Let's do H next. Over here, I'm foiling out the two brackets. Root 7 times root 7 is just 7. Root 7 times 1 is root 7. Negative 6 times root 7 is negative 6 root 7. Negative 6 times 1 is negative 6. 7 minus 6 is just 1. Root 7 minus 6 root 7 is negative 5 root 7. And another FOIL question over here. So 3 times 3 is 9. Root 5 times root 5 is 5. Then 3 root 5 times 2 root 3, that's 6 root 15. Negative 2 root 3 times 3 root 5 is negative 6 root 15. And negative 2 times 2 is negative 4. And then root 3 times root 3 is just 3. I can simplify this. These two terms just cancel out. 9 times 5 is 45. 4 times 3 is 12. So final answer is just 33. Question number 9, use the discriminant to find the roots for each quadratic equation. So my discriminant is b squared minus 4ac. So let's calculate it for this one. Negative 3 squared minus 4 times 1 times 1. I'll just do this in my calculator. It's a lot quicker than doing it manually. So I just get 5. If your solution is larger than 0, you know that we have 2 roots. Let's do it for this one. Negative 5 squared minus 4 times 2 times 7. Which is negative 31. If my discriminant is negative, I have no roots. Then last one over here is 24 squared minus 4 times 36. Which is just a 0. And if my discriminant is 0, it means I have one exact root. Next, we're solving quadratic equations, and we have to give exact answers for a question like this. So first one here, I'm just doing my man method. 1 multiplies to 12, adds to 7. That's just 4 and 3. It's a simple trinomial. I can write it in factored form instantly. And then I'll just get x equals negative 4, x equals negative 3 as my solution. Second one here is a complex trinomial. So I want to be a bit more careful. My m is negative 45. My a is negative 4. So my two numbers are negative 9 and 5. I'm going to break this down by grouping. So 3x squared minus 9x plus 5x minus 15. And then let me group it. So 0 equals 3x, x minus 3 plus 5, x minus 3. And then if I write it in factored form, it's just x minus 3 times 3x plus 5. So my two solutions here are 3 and negative 5 over 3. This one here, I got to start by moving the 1 to the other side. And then you can try your man method as a complex trinomial again, but nothing's going to multiply to 3 and add to 6. That's basically impossible. So we got to do quadratic formula over here. So x equals negative 6 plus or minus root of 6 squared minus 4 times 3 times 1 divided by 2 times 3, which is negative 6 plus or minus. Let's calculate that in my calculator. 24. And now I can simplify this because I know that I can turn 24 into 4 times 6. Then I can bring out the 4 outside the bracket. It's 2 root 6. And then I can simplify this by dividing all of these three numbers by 2. So if I do that, I'll end up with negative 3 plus or minus root 6 divided by 3. Let's try this next one here, which again, man is not going to work here because nothing multiplies to 4 and adds to 6. So again, we're doing quadratic formula over here. I'll simplify it. I can simplify my radical into root of 4 times 5. And I can take out the root 4, which is just 2. And I can divide everything by 2. So if I divide everything by 2, that'll just disappear. That'll disappear. That'll become a negative 3. So final answer is just negative 3 plus or minus root 5 because the over 1 does not mean anything. Okay, question number 11. Determine the coordinates of the points of intersection. So to find the points of intersection, we make the two functions equal to each other, and then we bring everything to one side and move these terms here. Then I can factor this with my man method. So what multiplies to negative 6 adds to negative 1. It's just negative 3 and 2. Simple trinomial, so I can do it instantly. So I know that x equals to 3 and x equals to negative 2 are my solutions for x, but I need to find the y values as well because these are points of intersection. Find the y values, I can sub in either of the two original equations. I'll always pick the linear one because it's easier. I sub in 3 over there. 5 times 3 is 15 plus 9 is 24. 5 times negative 2 is negative 10 plus 9 is negative 1. So those are my 2 points of intersection. Let's try for this second one over here. I'm going to move all of them to the right side so I can have a positive x square. I always like to do that. And then I'll factor this again with my man method. So what multiplies to negative 14 and adds to 5 is just 7 and negative 2. So 0 equals x plus 7, x minus 2. So x equals negative 7 or x equals 2. Do the y values as points. So negative 7, 2. Negative 7 minus 8 is just negative 15. 2 minus 8 is just negative 6. And those are my 2 points of intersection for this one. Given the equation of a parabola and the slope of a line that is tangent to the parabola, determine the y-intercept of the tangent line. So we have f of x here. We don't have g of x, but we have the tangent line has that slope. So I can write g of x equals mx plus b. It's a linear equation. And I know that the slope is 13. So g of x equals 13x plus b. I just replaced the slope with 13. I need to find the y-intercept here. So I'm going to equate these two equations together. And then I'm going to move everything to one side. I'll move everything to the right side because, like I said, I like to have the x square as positive always, but you can always move to the left side. You'll get the same solution. And then what I'm going to do is I'm going to use my discriminant formula and make it equal to 0 because anytime you have a line that's a tangent, it means that there's only one point of intersection, which means your discriminant has to equal to 0. So my B is 12, so 12 square. My A is 3. And then my C is B plus 4. And remember B over here, this B is the y-intercept. All I have to do is solve this equation now for my B and I'll get my answer. So 144 minus 12 B plus 4 equals 0. 144 minus 12B minus 48 equals 0. Combine those two like terms. So 96 minus 12B equals 0. Continue over here. I'll move the 12B to the other side. So 96 equals 12B. And then divide by 12 on both sides. And I just get 8 equals to B. So my y-intercept of my tangent line is just 8. Basically, think of it like this. You have a negative quadratic equation. You have a tangent line somewhere. And then we're just finding that y-intercept to be as 8. Okay, next we have some irrational expressions. So steps are factor, then state restrictions, and then simplify. So let's start with factoring. I can factor the bottom of this one with my man method. So it's just going to be x minus 7, x plus 3. Then I'll state my restrictions, which are based on the denominator. So x cannot equal to 7 or negative 3. And then I'll simplify. I can cancel out x minus 7, so I'm just left with 1 over x plus 3. Part B, we have complex trinomials on the top and bottom. So I'm going to factor them on the side with my man method. And I'll do this pretty quick, but you should know how to factor yourself. So what multiplies to negative 30 and adds to 7, it's 10 and 3. And I'll group it. And then I know that if I factor the top, it's just x plus 5 times 2x minus 3. I'll do the same with the bottom. It's a complex trinomial, so I'll factor it on the side. So what multiplies to negative 18 and adds to 3? It's 6 and negative 3. Factor by grouping. And then the bottom just factors to x plus 3 and 2x minus 3. I'll state my restrictions next. So looking at the bottom, x cannot equal negative 3 or 3 over 2. And then I'll simplify. I can cancel these out. I'm just left with x plus 5 over x plus 3. Let's go to part C next. This is already fully factored, so I'll just start by stating my restrictions, which is x cannot equal to 0 because I just have x and x squared on the bottom. Then I'll multiply the top with the top and the bottom with the bottom. So I get 2880x7 over 60 x cubed, and then I'll simplify. 2880 divided by 60 is just 48. X7 divided by x3 is just x4. Part D, I'll start by flipping my divide into a multiply. Then I'll state my restrictions. In this case, both x and y cannot equal 0. Then I'll just multiply the top with the top and the bottom with the bottom. From the top, I get 288xy, and in the bottom, I get 864x squared y, and then I'll just simplify this again. So 288 divided by 864 is just 1 over 3. Actually, and then x cancels with the square, y cancels with the y, so I'm just left with an x in the bottom. Final answer is 1 over 3x then. Part E, that's already fully factored, so I'll just start by stating my restrictions. X cannot equal -2 and 6, and then I can just cancel the x plus 2's. So I'm just left with x minus 8 over x minus 6. Part F, I need to factor first. Common factor in the top, common factor in the bottom, nothing to factor over here, and a common factor in the bottom. I'll state my restrictions next. So x cannot equal 0, -6, or 5. And then I'll simplify. X minus 5 and x minus 5 cancels. 3 and 3 cancels. X and the square cancels. So on the top, I'm left with 4x. On the bottom, I'm just left with x plus 6. G is a division. I'm going to start by flipping it into a multiply. Then I'll state the restrictions. X cannot equal 0 or -1. And then I'll simplify. X plus 1 cancels. X cancels, and I'm just left with 2. H is a division, and I also have to factor, so I'm going to do both those things in the same step. Top is man method, which is pretty easy. X minus 2, x minus 5. Bottom is a difference of squares. X minus 2, x plus 2. I'll flip this. I'll factor the bottom and write on the top. It's a common factor of 3. And over there, I will factor in the bottom. It's a simple man method again. X minus 5, x plus 1. I'll state my restrictions next. So x cannot equal 2, -2, 5, and -1. And then I'll simplify. So x minus 2 cancels, x minus 5 cancels, x plus 2 cancels. I'm just left with 3 over x plus 1. All right. Next question is a subtraction. So now we have addition and subtraction questions. We need to make a common denominator. The first thing I'm going to do is always factor. Difference of squares on the bottom there. Once I factor, I'll state my restrictions. So x cannot equal 2 or -2. Then I'll make a common denominator. So on the top and bottom here, I have to multiply by x plus 2 to have a common denominator. 2x, x plus 2, minus 3. And now my common denominator is x minus 2 times x plus 2. Then I just need to simplify the top. I'll multiply the 2x into the bracket. And then after that, if you had any like terms, you would combine them. But since there's no like terms in the top, that's just my final solution for this question. Let's try the next one over here. Again, I'm going to factor the bottom over there. That's just a simple trinomial. I'll make a common denominator, but before that, state my restrictions. X cannot equal to -2 or -4. Over here, I'm multiplying the top and bottom by x plus 4 to make a common denominator. So I have x minus 2, x plus 4, plus x plus 10, and then I have a common denominator of x plus 2, x plus 4. The next thing I'll do is I'll FOIL out those two brackets. X squared plus 4x minus 2x minus 8 plus x plus 10. Denominator just stays the same. Then last step, I'll combine like terms in the top. X squared, 4x minus 2x plus x, that's 3x. -8 plus 10 is 2 over x plus 2, x plus 4. And as we see, this question is actually a trick question because normally the questions end over here. And this one, I can actually factor the top because it's a simple trinomial. And I can actually simplify this one further, which is quite surprising because usually that does not happen. But like I said, this is kind of like a trick question. So these can cancel, and my final answer here is actually x plus 1 over x plus 4. All right, let's go to this one over here. Again, I'm factoring in my first step, so common factor. Bottom is a simple trinomial. Common factor here again. And bottom is a simple trinomial again. I'll state restrictions next. So x cannot equal -7, 5, 10, and 2. And then the next thing I'll do is I'll cancel out these because they're identical in the same ones. So I can cancel out on the top and bottom of the same ones if there's a plus, but not across. Let's keep that in mind. So now I have 4x over x plus 7 plus 3 over x minus 10. And then I want to make a common denominator, so I'm going to cross multiply those two. So I have 4x times x minus 10 plus 3 times x plus 7, and this is all over x plus 7, x minus 10. I'm just going to expand the top. We'll continue over here. So 4x squared minus 40x plus 3x plus 21 over x plus 7, x minus 10. And then if I combine like terms, I'll just be left with 4x squared minus 37x plus 21 over x plus 7, x minus 10. So this one is going to be the final solution. I don't think you can factor that, and I wouldn't bother trying because it's pretty hard. It's very unlikely something will cancel out. That previous question, like I said, is a very rare exception, and only if it's super easy to factor like that, then you should do it. Okay, let's try and squeeze in this last part over here. It's not too hard of a question. So if I notice these two over here on the bottom, they're kind of the same, but they're backwards. So what I can actually do is I can rewrite this as 3x plus 2 over 3 minus 4x, and I can factor a negative out of the bottom. So negative times positive is just negative. And then 2x plus 1 over 3 minus 4x. So that's how I make the denominator the same in this one. Next, I can write this all with my common denominator. So 3x plus 2 minus, make sure you put a bracket here. That's something most people miss. And we have a common denominator of 3 minus 4x. I'm going to distribute the negative into the bracket. Last step, I'm going to combine like terms. So 3x minus 2x is just x, 2 minus 1 is just 1. And that will be my final answer to this question. For the restriction here, it's just x does not equal to 3 over 4. It's the same restriction for both of them in this case. Oof, a lot of questions there. Let's go to number 14 next. We're going to transformations now. Also, I do not think I will be able to do this all under 2 hours. Maybe, but I don't think so. Probably gonna have to split this into 2 videos. Number 14, we have a function, a root function, and we need to write it with the transformations. So 4 units up, right 9 units. So right 9 units means it's x minus 9 and then plus 4 out there. Vertical stretch by a factor of 6 means the 6 is outside the root, and left 5 units means x plus 5 inside the root. Horizontal reflection means a negative inside the square root. Horizontal compression is again inside. So remember, stretches and compressions are flipped upside down. So I'm going to go square root, negative for the reflection. The compression, I'm going to flip that. So negative 4x. Next question, we're listing all the transformations of the following functions. So always go left to right. Negative outside is a reflection in the x-axis. And then -3 is just right 3 units. And -4 out there is down 4 units. Part B, again, we have a reflection in the x-axis. 1/3 is a vertical compression. 2 is a horizontal compression, and remember we have to flip it upside down, and then +10 is up by 10 units. Part C, we have a vertical stretch by a factor of 5. Then we're going left 4 and down 5. Part D, we have a reflection in the x-axis. Vertical stretch by a factor of 2. We have a reflection in the y-axis. Then we have a horizontal stretch, and we need to flip that upside down, so it's by a factor of 6, and then we're going up 6 units. Okay, question 16, state the parent function, create a table of values, and then map the image points, and then graph the function. So I'm going to do this again relatively quickly, so my graphs might not be super tidy. Parent function over here is x squared. For an x squared function, my original table of values is -2, -1, 0, 1, 2. My y values are 4, 1, 0, 1, 4. I'll do my mapping rule over here. So for the x, it's just x plus 2. For the y, it's 1/2y plus 5. And then I'm just going to map the x points. I'm going to add 2 to all the x points. So I'll have 0, 1, 2, 3, 4. I'll do this calculation for the y values. So that's just 7, 5.5, 5, 5.5, 7. And then you want to draw out the mapped function over there. So 0, 7, 1, 5.5, 2, 5, 3, 5.5, and 4 and 7. So those are the 5 points over there. And then you just want to draw a parabola through those points. Next one is for square root function. Parent function is square root of x. For square root function, the x values are 0, 1, 4, 9. The y values are 0, 1, 2, 3. I'll do my mapping rule. So for x, it's going to be 1/2x, because we flip that. And then for the y, it's just 1/2y minus 3. Let's transform all my x values. So 0, 0.5, 2, 4.5. Let's transform my y values. -3, -2.5, -2, -1.5. And then I'll plot it out. 0 and -3, 0.5 and -2.5. 2 and -2, 4.5 and -1.5. So those are my 4 points over there. Sketch it out, put an arrow at the end, and that is my graph in this second one. Next one is for a 1/x function. So original values are -2, -1, 1, and 2. And -0.5, -1, 1, and 0.5. So for this one, it gives us the function in function notation and tells us to create the table of values of the image points. So I'll do my mapping rule next. It's just x minus 2. and y minus 1. So I'll do all my new points next. -4, -3, -1, 0, -1.5, -2, 0, -0.5. And then the first thing you want to do is, I guess we can just write down the equation. We'll just cover that first. So it's just 1 over x plus 2 minus 1. My vertical asymptote is just at -2. And my horizontal asymptote is just at -1. You want to always draw out your asymptotes first. Then we'll put our points. So -4 and -1.5, -3 and -2, -1 and 0, and 0 and -0.5. So those are the points on this side here. It's just going to look like that. And on this side over here, it's just going to look like that. And that's the transform function g of x right there. All right, let's go to question number 19 next, finding the inverse algebraically. So I'm going to switch my x and my y, and I'm going to isolate the y. So I'll start by subtracting 2. And I'll divide by 2. Then I will square root, and when I square root, I have to put a plus or minus. And then I'll move the 1 over to the other side. So the inverse equation is just going to be 1 plus or minus root of x minus 2 over 2 equals g inverse of x. Okay, so for the function from the previous question, make a table of values for the parent function, which is x squared. So -2, -1, 0, 1, 2, 4, 1, 0, 1, 4. Graph g of x by creating a table of values of the image points. So we'll do our mapping rule over here, which is x plus 1 and 2y plus 2. So let me map all of these points here. So this is -1, 0, 1, 2, 3. And over here it's 10, 6, 2, 6. Oh, wait, I made a mistake. That's not 6. 2 times 1 is 2, plus 2 is 4. And then 10. And then it wants us to do the inverse points. For the inverse, I just have to flip my x and y. So 10 minus 1, 4, 0, 2, 1, 4, 2, 10, 3. So I have to graph these two over here. Let's start with graphing g of x. So -1 and 10 is right over there. 0 and 4, 1 and 2, 2 and 4, and 3 and 10. So that's the original g of x function over there. And then let's graph the inverse function. So 10 and -1. 4 and 0. 2 and 1. 4 and 2. And 10 and 3. So just a sideways parabola basically, plus or minus root function, that's g inverse of x. Okay, we are going to get into the next chapter now, which is exponential functions. So there's over 50 questions and I'm not even halfway through yet. So this will probably turn out into 2 videos. I'm gonna try and get through it right now, but I don't think I'll have time to do the whole thing in one shot. Insect colony has an initial population of 15, number of insects quadruple per day. So we're just using our a b to the x equation over here. Sometimes you might have a k or a p in the bottom, but in this case we don't, because it quadruples every day, so my k is just 1. So let me just start by writing the equation here. Just going to write it as, I'll write in function notation. P of t equals, initial population is 15, it quadruples 4, so exponent of t. Remember, t is in days, so when they ask us in 1 week, we're doing P of 7, which is 15 times 4 to the power of 7. And if I put that in my calculator, I get 245,760 insects after 1 week. Similar idea here, population of an ant colony doubles every week. So P of t, this one is in weeks though. Initial is 213, doubles, so 2, and then exponent of t. And then we need to find P of 4, which is 213 times 2 to the power of 4, which is 3,408 ants. How long will it take the population to reach 109? So we're just replacing the y, and we're trying to solve for t. So I'm going to start by dividing by 213 on both sides. And then over here, you can either use logs to solve this, or you can just use exponents and guess and check. I'm going to use exponents and guess and check because most grade 11 students don't know how to use logs. So my calculator, I'm trying 2 to the power of random numbers to give me 512. I know that 2 to the 9 gives me 512, so I can cancel out the bases, and p just equals to 9 weeks. So it'll take 9 weeks for the ant population to reach that value. Question number 13, population of a town starts off at 20,000, grows by 13% each year. Find the population after 10 years. So P of t equals, my initial value is 20,000. Population increases by 13%, so I'm doing 1 plus 13 over 100. It's 20,000 times 1.13 to the power of t. And then I'm trying to find P of 10. I'm just replacing my t with 10. And I'll round this to a whole number because you can't have decimal number of people. So 67891 people. Okay, bacteria culture starts with a population of 12,000 and doubles every 4 hours. So now we have a K value. So P of T equals, initial value is 12,000, doubles. So my rate is 2, and it doubles every 4 hours. So my period is 4. And I need to find how many bacteria are present after 12 hours. So I'm just subbing in 12 for my T. I can simplify that to 2 to the power of 3, and then I'll do this in my calculator. I just get 96,000 bacteria. How many bacteria are present after 1 day? So 1 day is 24 hours. So I'm just doing P of 24. And if I put that in my calculator, I will get 768,000 bacteria. How long will it take for the population of the bacteria to reach this value? So I'm just subbing in that huge number for my Y value. And I'm solving for my X. And I just get, if I divide both sides by 12,000, at 4096 equals 2 to the power of t over 4. Next, I want to make the bases the same, so I need to figure out 2 to the power of what number gives me 4096, and that is 2 to the power of 12. Now I can cancel the bases and solve for the exponents. So 12 equals t over 4. If I multiply the 4, I'll just get 48, R's equals t. Next, we have a half-life question. We start with 40 milligrams, and the half-life is 20 days. So our equation is, I'm just going to use f of t for this one. Initial value is 40. Half-life question means that I put a half in the bracket, and exponent is t over the half-life, which is 20. And then after 10 weeks, so 10 weeks is 70 days, so I need to find f of 70. Remember this question, the half-life is in days, so this equation is all based in days. Now I'll just put this in my calculator. And I just get 3.53 milligrams is left after 10 weeks. How long will it take for the polynomial to decay to 8% of its initial mass? So let me find what 8% of the initial mass is. Do that on my calculator, I will get 3.2. So I'm replacing the y value with 3.2, and I'm solving for t. I'll start by dividing both sides by 40. So 0.08 equals 1 over 2 to the power of t over 20. And now I need to make the bases the same. So I need to figure out 1 over 2 to the power of what number gives me 0.08. I'll try that on my calculator. I'm getting close. Decimal value though. And I get that to be as 3.64 by guess and check. But if you know how to do logs, you can just do logs there. So now I can cancel off the bases. So I have 3.64 equals t over 20. I'll cross multiply the 20. And I will just get 72.8 days equals t, that's how long it takes to decay to 8% of its initial mass. Okay, number 26. Daniel is very excited about his new motorcycle. Motorcycle costs this much, resale value depreciates. So let's start with the equation. We'll do cost. So cost of based on time. So initial value is 13,500. Depreciates by 20%. So that's 1 minus 20 over 100 exponent of t. And then if I do the calculation, it's just 0.8 the power of t. And then I'm trying to find c of 6. 13500, 0.8 to the power of 6. Which is $3,538.94. So that's a huge depreciation going from 13,500 to that low value after 6 years. How long will it take for Daniel's motorcycle to depreciate 50% of the original cost? So 50% of that is just 13500 over 2. Is 6750. So I'm just subbing that in for the cost. And I'm solving for my t. So I'm going to divide both sides by 13,500. And then again, you can either use logs or guess and check here to solve this. Maybe I'll show this one using logs because I've been using guess and check all this time. So if I'm doing logs, I'm going to log both sides and bring down the exponent. Then I'm just going to divide both sides by log 0.8. So if you don't know this method, just use guess and check. I just get 3.1 years equals t. Okay, next questions are investment questions, but they're all compounded annually. So because they're compounded annually, we can just use the same formula for exponents. If they're compounded semi-annually and things like that, then we'd have to use the finance unit. So I guess I'll just put the finance formula here. Why not? Technically, you should know this going into your final exam. So we'll just use the finance formula. How much should you invest now? So we're trying to find P. We need 13450. My interest rate is 0.07 over 1. And it's 9 years, so my exponent is 1 times 9. I'll simplify this equation. Then I'll just divide this on the other side. And then I'll put this in my calculator. Which is $7315.91. So you need that much if you want that much in the future. Jacqueline deposits an inheritance of 1,500 into an account, 3.5. How much is in the account after 8 years? Exact same formula over here, but we're trying to find the future value. Present value is 1,500. Interest rate 0.035. It's compounded annually. And then it's 1 times 8 years in the exponent. So that's just 1,500, 1.035 to the power of 8. Which is 1975 $1.21. So that's how much that's going to be in the account after 8 years. How long will it take for the money to double? So double of 1,500 is 3,000. I'm not even going to put the over ones because it's annually, and over here I'm just going to put t instead of n because I know it's 1 times t. I just have to solve this now, so I'll start by dividing both sides by 1,500. 2 equals, that's just 1.035 to the power of t. And again, now we can either use logs or we can use guess and check. I'll just do guess and check over here, the logs in the last one. So 1.035 to the power of what number gives me 2? I'll test in my calculator. So 1.035, start with like something like 20 maybe. Oh, that's pretty close. 21, it's too high, so 20.5, 20.4, 20.2, there we go. 20.2, I can cancel the bases. I know that t equals 20.2 years. If you did log 2 divided by log 1.035, you should get the exact same answer. Let me test that in right here. I do. I get 20.15, which is pretty much the same as that. Okay, so now we have two different types, compounded annually and quarterly. So let's start with the first one, annually, which is 5,001 plus 0.04 over 1. And the exponent is 1 times 10. Simplify it, 1.04 to the power of 10. And if I put this in my calculator, $7,401.22. Now over here it's compounded quarterly, so it's 5,001 plus 0.04 divided by 4. Exponent is 4 times 10. Simplify that, 5,000, 1.01 to the power of 40. And if I put that in my calculator, it should be slightly higher than that value. And I get 7,444.32. Next question, we're matching each graph with the corresponding equation. So let's start with this one here. This is exponential growth. There's no reflections. And I can calculate the y-intercept. So 3 to the power of 0 is 1. 1 times 3 is 3. So it's right here. Exponential growth, no reflections, y-intercept is 3. Let's look at part B. This is exponential decay. There's no reflections. Calculate the y-intercept. 1 over 3 to the power of 0 is 1. 1 times 3 is 3. So that's this one over here, which is decay. Y-intercept is 3. This one here is growth again. 3 to the power of 0 is 1. 1 times 1 over 3 is 1 over 3. So growth with the y-intercept of 1 over 3. That's this one over here. Last one here is growth, but with a reflection in the y-axis. 3 to the power of 0 is 1 times -1 is -1. Does match this final option here, which is a reflection in the x-axis, has an intercept of -1. Okay, next question here, we got to state the parent function. Parent function is just 1 over 2 to the power of x. Create a table of values of image points and then graph and include asymptotes. Okay, so for an exponential function, the x values -2, -1, 0, 1, 2, doesn't matter which you pick. The y values we sub in the original equation. So 1 over 2 to the power of -2 is 4. 1 over 2 to the power of 2, 1, 0.5, 0.25. Do our mapping rule next. So my mapping rule for this one, I have no k value. I have a d value 1, so it's x minus 1, and then -2y minus 1. So let's subtract 1 from all of those. -3, -2, -1, 0, 1. Let's do all the y values. -9, -5, -3, -2, -1.5. So now we'll graph the function. We know that the horizontal asymptote is at -1. So that's the first thing I always draw my asymptotes. Then I'll put all my transform points there. So -3 and -9, -2 and -5, -1, -3, 0, -2, and 1 and -1.5. So those are my 5 points there. And then I'll just draw the function. Make sure it hugs the asymptote on this side, and on the other side, it's just going down. Oh, done with exponentials. We're on to the next unit, trigonometry. So let's start by drawing the two special triangles. You shouldn't have these memorized. One of them is 30, 60, and that's 90. And opposite of 30 is the smaller side, which is 1, larger side, and hypotenuse is 2. And the other special triangle is just 45, 45, 90, 1, 1, root 2. So first question says find a reference angle for the following obtuse angles. So when it says reference angle, I don't know if it means can't be acute angle. So to find the reference angle, I guess it just means a cotonal angle. We can either add or subtract 360 there. I don't know if it means like, so -137 is over here. So I know that the principal angle, I can do 360 minus 137, which is principal angle is 223 degrees. I don't know if that's what they mean by a reference angle. And the acute angle is just that tiny one over there, which is 137 minus 90. The acute angle is 47 degrees. Oh no, 57 degrees. Oh no, what am I doing? 137, no, 43 degrees. So I'm doing 223 minus the 180 to just get that. I don't know if the reference angle is referring to theta or beta or what exactly. 330 degrees is in my fourth quadrant over there. The acute angle is 30 degrees. So if you want to call this beta is 30 degrees, if you want to find another principal angle, we could do it as just -30 degrees because it's in the opposite direction, or you could just add 360 as well. Doesn't matter. From the exact values of the following trig ratios. So if you're not allowed a calculator that gives you exact values, you need to do this using the special triangles. But if you're allowed a calculator, you can just use a calculator over here. So I'm going to do it with the non-calculator method. So 330 degrees is in the fourth quadrant. Acute angle is 30 degrees, which means that Using this special triangle here, opposite is -1 because it's a negative quadrant, adjacent is √3. Hypotenuse doesn't really matter because we're doing tan here. So tan is opposite over adjacent, which is -1 over √3. And if you have to rationalize, -√3 over 3. You could always type it in your calculator if you're allowed, and it should give you the same answer. But like I said, I'm going to do this one without a calculator. 135 degrees is in quadrant 2. Acute angle is 45 degrees. So I'm using this triangle here. Positive 1 there, -1 because the negative x-axis. Hypotenuse is √2. Sine is just opposite over hypotenuse, so 1 over √2, which just simplifies to √2 over 2. Quote 300, so 300 degrees is in the fourth quadrant. Acute angle is 60 degrees, which means the opposite is -√3. Adjacent is +1. Hypotenuse is 2. Tan is opposite over adjacent, so quote is adjacent over opposite. So 1 over -√3, which just simplifies to -√3 over 3. Sine 270. 270 is not in any of the 4 quadrants. If you're not in any of the 4 quadrants, you just use a sine graph. 90, 180, 270, 360, 1, -1. Sine of 270 is just -1. Then cosec of 150. 150 is in quadrant number 2. Acute angle is 30 degrees. Opposite is 1. Adjacent is -√3. Hypotenuse is 2. Cosec is the reciprocal of sine. Sine is opposite over hypotenuse. So cosec is hypotenuse over opposite. So 2 over 1, which is just 2. You can always double check these in your calculator. Make sure kind of get the right solution as well that way. Question 35, determine two angles that are coterminal with the angle 30 degrees. So you just have to add 360. So it's going to be 390 and then add another 360 and you'll get 750. Okay, question number 36. We are solving these using our cast rule. Anytime you have solutions between 0 and 360, you always have to use your cast rule. So let's start with this one over here. Tan is positive in A and T. To find the acute angle, I'll do the tan inverse of 0.32 in my calculator. And it's going to be 17.7. Then my first solution for my principal angle is just 17.7 because that's in quadrant 1. My second solution is 180 plus 17.7, which is 197.7 degrees. Let's try part B. Sine is negative in third and fourth quadrant. To find the acute angle, I'll do the sine inverse of positive 0.46 in my calculator. Now put negatives for the acute angle. Get 27.4. My first solution is 180 plus 27.4, which is 207.4 degrees. And my second solution is 360 minus 27.4, which is 332.6 degrees. Part C, again, I'll start with my cast rule. Sine is positive in the first two quadrants. You can do this one with your special triangles as well, or you can use a calculator, but both ways you should get the acute angle to be 60 degrees. First solution is just 60 degrees, and second solution is 180 minus 60, which is 120 degrees. Fourth one here, I'll start by converting this to tan theta equals -1 over √3, and then I'll solve it. Then I'll do my cast rule. Tan is negative in the second and fourth quadrant. I'll do the tan inverse of 1 over √3 or use my special triangle. Find the acute angle, which is 30 degrees. And then my two solutions for the principal angle here are 180 minus 30, which is 150 degrees, or 360 minus 30, which is 330 degrees. Cos A equals -8 over 17. Angle A lies in the second quadrant. Find the other two primary trig ratios. So pretty simple. We're drawing this out. Angle A lies in the second quadrant. I'll draw a triangle there. Cos A is -8 over 17. So cos is adjacent over hypotenuse. So adjacent is -8, hypotenuse is 17. Use my Pythagorean theorem to find my opposite side. And I get that to be 15. It's positive 15 because that's the y-axis. So looking at this triangle over here, that's my principal angle A. Sine A is just opposite over hypotenuse, which is 15 over 17. And tan A is just opposite over adjacent, which is 15 over -8, which just simplifies to -15 over 8. Oh, making good time. Already on question number 38. I might be able to get through this whole thing in one go. I only have about 45 minutes left before I have to stop this video. So let's see if I can finish the rest of the questions in 45 minutes. So point lies on the terminal arm in standard position. Determine exact expressions for all 6 trig ratios. So we're going to draw this out. -12, -5 is this quadrant here, and we always draw the triangle with the horizontal line. X value is -12, y value is -5. I'll find the hypotenuse with my Pythagorean theorem. Well, I get my hypotenuse to be 13. Hypotenuse is always positive. So let's do the 6 trig ratios. Sine theta equals opposite over hypotenuse. Cos theta equals adjacent over hypotenuse. Tan theta equals opposite over adjacent. The negatives will just cancel, it'll turn positive, and then the reciprocals. Cosec is the reciprocal of sine. So let's flip that, we'll leave the negative. Sec is the reciprocal of cos. And cot is the reciprocal of tan. To solve each of the following triangles, so for this triangle, I'm going to start by finding angle A first using my cosine law. So A square equals B square plus C square minus 2 times B times C cos A. I'll do 42 squared first. Then I'll do 21 squared plus 28 squared. And I'll do 2 times 21 times 28. And I'm going to subtract the 1225 on the other side. Divide by -1176. My handwriting might get a bit untidy because I'm going to be rushing now to try and complete this at the end. And last step, I'm going to do the cos inverse. And I'm just going to round it to a whole number because it doesn't specify in the question. So I will round it to a whole number. So angle A It's just 117 degrees. I'll find angle B next using my sine law. Sine B over 21 equals sine 117 over 42. I'll cross multiply the 21 over. Then I'll put this in my calculator. It's 0.2599, and I'll do the sine inverse of this. And I'll get B to be 15 degrees. And then to find C, it's pretty simple. I just have to do 180 minus those two. 180 minus 117 minus 15 is just 48 degrees. Let's try part B. Part B is a right triangle. I can just find this angle first by doing 180 minus 90 minus 27 and get 63 degrees. And I can find the bottom side here using SOHCAHTOA. So I'll just do tan 63 equals opposite, which is small c, over adjacent, which is 9. I'll cross multiply the 9 over. 9 tan 63 equals c. Put that in my calculator and I get 17.7 meters equals c. And then I'll just find b using my Pythagorean formula. B is the hypotenuse. 9 square plus 17.7 square. B square equals, I'll just do this all in one step just to save a bit of time. But in your test, make sure you show more steps. Then I'll just square root that. And I get B equals 19.9 meters. And I've solved this second triangle here as well. Okay, next one, we have a 3 problem here. And I think all the information is given in this diagram. We need to find the angle of elevation if Rhonda looks up at Dave. So we're trying to find that over there. But what I'm going to do is I'm going to start by just drawing this out as 2 separate triangles. So my first triangle, the bottom triangle like that. Oops, that's a really bad triangle, but I'm not going to redraw it. It's split exactly in the middle because of the 2 lines. So keep that in mind that this is an isosceles triangle. And this full angle is 64 degrees. This is 3.4 kilometers. This is 4.6 kilometers. It's actually not an isosceles triangle because these 2 distances are different, but this is still the same as this length here. Those 2 lengths are the same. And then we have the right triangle over here. And this bottom side is the same as this over here. So I'm just going to call this x and this x. And then I know that this is 400 meters. So I'm going to change it to 0.4 so that the units are the same, kilometers. And the question is asking me to find the angle of elevation, which is theta. So that's all the information I've been given in this question. So I need to basically find x using this triangle over here. To find x, I know that if this distance is the exact same as this distance, this angle, would it be split in 2? Probably not. Yeah, definitely not, because I can't just break this angle into 2. Like I can't just divide 64 by 2, because imagine if that was like super long, that was like super short. The angles are not going to be the same, even if this hits the midpoint. At least that's what I believe. But it is possible that the angle will be, because if I split the angle in two, then SOHCAHTOA will not work. It won't give me the same answer for this. So what I have to do is I have to use cosine law, and using cosine law, I need to find the length of this side here, and I need to split that side into two. You cannot split the angle into two. That will not work in a question like this. So almost a trick question. So let's use my cosine law. I'm going to call that side y up over there. So y square equals 4.6 square plus 3.4 square minus 2 times 4.6 times 3.4. Handwriting is getting really bad now, I know, but my hand's hurting and I'm also rushing to try and complete this all in one go. I get exactly 19, and if I square root that, I get y equals 4.36 if I round to do 2 decimal places. So if I know that this full side over here is 4.36, I can split it into half and just find that half length over there or that half length there, whichever one, it doesn't matter. They're both going to be the same. So 4.36 divided by 2 is 2.18. And now I can use either the left triangle or the right triangle to find x by using, how would I find the height over there? Oh yeah, I can just do Pythagorean theorem. Or can I? No, can't do Pythagorean theorem. That's not a right angle triangle. That line over there is not, that's not 90 degrees. So if I have this side, and I need to find middle, but I don't have an angle. I guess I have to find another angle first in this big triangle. So I'm going to find this tiny angle over here. I'm going to call it beta. And to find this beta over here, I'm going to look at the big triangle, and I'm going to use sine law. So sine beta over 4.6 equals sine 64 over 4.36. I'm going to cross multiply the 4.6 over. It's a tough 3D problem, a lot of steps. Get 0.9483, and then if I sine inverse, I'll get 71.5 degrees. That's 71.5 degrees. Now I can find x over here in this tiny triangle by using cosine law again. Wow, this is a lot of steps. I don't know how a teacher expected you to fit this all over here, but I'm going to do my cosine law. So x squared equals 3.4 square plus 2.18 square minus 2 times 3.4 times 2.18 cos angle is 71.5. I'm going to put that all in my calculator. I'll get 11.6, then I'll square root that, and I get 3.4 kilometers is basically x. So in this triangle here, I can put this as 3.4 kilometers. We know this is a right angle triangle. For sure, it's even given over there. And now I can just use SOHCAHTOA to solve for theta. So I'm doing tan theta equals opposite over adjacent. And then I'll just do the tan inverse of this. So tan inverse of 0.4 over 3.4 is just 6.7 degrees. Okay, hope that question made sense. I know I did a lot of it really quick, but like I said, running out of time. I only have 30 minutes to finish the rest of this document. Let's get to trig identities next. Going to work on the left side for this one. I'll convert sec to 1 over cos. And over here as well. Cos and cos cancel, so I'm just left with 1. 1 times sine is sine over cos, and then sine over cos is just tan and matches the other side. Second one over here, again, I'll work on the left side. Cos square plus sine square is just 1. Tan is sine over cos. I'll make a common denominator, so multiply the top and bottom over here by cos square. Sine square plus cos square is just 1. Now it matches the other side. Again, I'll work on the left side here. I'll make a common denominator, multiply 1 minus sine on the top and bottom there, and 1 plus sine on the top and bottom here. My common denominator is 1 plus sine times 1 minus sine. I'll combine like terms in the top. So negative sine and sine cancel. 1 plus 1 is 2. I'll expand the bottom using my FOIL. Cancel out like terms. So I have 2 over 1 minus sine square theta. 1 minus sine square is just cos square theta, and 1 over cos square is just sec square theta, which matches the other side. And this one here, again, I'll work on my left side. It's definitely more complicated. So I'll start by just converting everything to sine and cos. I'll also convert the major fraction into a division. So cos is cot over sine. Tan is sine over cos. And then this is going to be divided by sine times cos. I'll make a common denominator in here next. Multiply the top and bottom here by cos. And the top and bottom here by sine. Common denominator sine x cos x. Then over here, divided by sine x cos x. Next, I'll turn the divide into a multiply and flip it. Sine square x over sine x cos x times 1 over sine x cos x. I'll multiply top and bottom and bottom. So cos square minus sine square times 1 is just cos square minus sine square. Bottom, sine times sine, so that's just sine square x cos square x. Next, I will split the denominator. And the reason I'm splitting the denominator is because I have two individual terms over here. So I have cos square x over sine square x cos square x minus sine square x over sine square x cos square x. A bit hard to see, but squeeze it in. Cos square and cos square cancel here, so I'll be left with 1 over sine square x, and over here sine square and sine square cancel, so I'm left with 1 over cos square x. 1 over sine square is just cosecant square x. 1 over cos square is just sec square x, and then it matches the other side. Graph the function of this, and then using the key points, and that's pretty simple. You should know this. 0, 90, 180, 270, 360. There's no transformations even. So 0, 1, 0, -1, 0. First point 0, 0, 91, 180, 0, 270, -1, 360, 0. So sine function, pretty simple there. You'll probably get one with transformations in your exam. I'd be surprised if you got something this simple. Cos function 0, 90, 180, 270, 360, 1, 0, -1, 0, 1. First point, second point, third, fourth, fifth, and then draw your cosine wave going through those 5 points. Okay, now we're going to graph transform functions. So amplitude of this one is just 1, the number in the front. Vertical shift, just your equation of axis, which is 1 basically. If you had equation of axis, you would write y equals 1. Period is 360 divided by k. K is 1, so it's just 360. Phase shift is 60 degrees left. Max is your axis plus your amplitude, so 1 plus 1 is 2. Min is your axis minus your amplitude, so 1 minus 1 is 0. And then we can start to draw this out. The first thing that I do is I always put the equation of axis. I'm going to label that over there as 1. So I'm going to do 2 blocks as 1 because they don't label the y values as first. So every 2 blocks is 1 unit. So this is a sine graph. A sine graph normally starts on the axis, but we're phase shifted 60 degrees to the left. So this is my starting point right here at 1 and -60. That's -90 there. So each block is 30. That's my starting point at -60. I'm going to do my period divided by 4 always to find out my next point. Period divided by 4 is 360 divided by 4, which is 90 degrees. So my next point for a sine graph, positive sine graph, is the maximum value. A maximum, remember, is at 2, which is over there. And we're going 90 degrees to get to that max. So 90 degrees is 3 blocks. So 1, 2, 3 blocks is my maximum value. Next point is axis. So 1, 2, 3 blocks. Remember, we're going 90 degrees for each next point. 1, 2, 3 blocks. Minimum is at 0. 1, 2, 3 blocks. And it says sketch 2 cycles. So a second cycle is not going to fit on this side, so I'm going to continue to the left to get the second cycle in. So 1, 2, 3 blocks. 1, 2, 3 blocks. 1, 2, 3 blocks. And 1, 2, 3 blocks. So that's 2 complete cycles. Now I'm just going to sketch it through. Oops. A bit messy, but I think you get the idea. Let's try it for the second one, which is a positive cosine function. So amplitude is 2, vertical shift is -1. K value is 3, so period is 360 divided by 3, which is 120. Phase shift is 90 degrees right. Maximum is axis plus amplitude, so -1 plus 2 is 1. Minimum is -1 minus 2, which is -3. And then I'll do period divided by 4, so 120 divided by 4 is 30 degrees. Again, I'll start with putting the axis, which is -1, and I will put that for 2 blocks again. Make every 2 blocks 1 unit. Maximum is 1. and minimum is negative 3. Okay, so after I label my max and my min, I will do my starting point. A coarse graph, positive coarse graph starts on the maximum, but this is phase shifted 90 degrees to the right. So I'm phase shifted 1, 2, 3 degrees to the right. Now every next point is 30 degrees away, which is 1 block away. The next point is 1 block away there. Minimum is here, there, 1 block away there. And I can fit my second one over here pretty easily. So I'm just going to do the second cycle right over here. And then I just have to sketch this. That is 2 complete cycles of this one. Write the equation of the sine and cosine functions to match each graph. So let's start with this first one over here. I always find my equation of axis first, which is max plus min divided by 2. You could also do this off the graph straight away. I'll just show the calculation here. So it's 0. Next, I'll find my amplitude, which is max minus min over 2, which is just 0.75. And then I will find my period. My period is just the distance from one max to the next max, or one min to the next min, or I can even look at one sine wave. I can see clearly here one sine wave starts at 0, ends at 90. So my period is 90. K is 360 divided by a period. So my K value is 4. And now let's start by writing the 2 functions for this one. Let's start with the sine function. So I know that this graph has no phase shift. It just starts as a sine function. So I'm going y equals, my amplitude is 0.75 sine, K value is 4x. There's no phase shift for the sine graph. And then I'm doing plus my equation of axis, which is 0. So I don't even need to write that. And then let's do the cosine equation for this one. Y equals 0.75 cos, K value doesn't change, but now I have a phase shift because my cos graph starts all the way up over there. So what's the x value there? It's between 0 and 45, which is 22.5. So my phase shift is 22.5 degrees to the right. So that would be my cosine equation for this one. Let's try for part B over here. Max is 5, min is -1. So equation of axis is 5 plus -1 over 2, which is just 2. Amplitude equals 5 minus -1 over 2, which is 3. The period of this function, to find the period, I'll go from one max to the next max because they're easy to read. This one here is 90. Now it's hard to tell on the camera. This one here is -630. So the distance from 90 to -630, that's just 90 minus -630, which is 720. So my period for this graph, I did max to max, it's 720. K is just 360 divided by 720, which is 1 over 2. And now I can write the 2 equations for the sine and cosine function. Looking at the y-intercept here, this neither starts at the max or the axis point, which means there's going to be a phase shift for both the sine and the cosine wave for this function. Let's start with the sine graph. Y equals, my amplitude is 3 sine, my K value is 1 over 2, x, and then a sine graph would start right here on the axis. So it's phase shifted 90 degrees to the left, so x plus 90. And then my equation of axis is plus 2. And then let's do the cos equation. So y equals to 3 cos 1 over 2. Cos graph starts at the top. That's phase shifted 90 degrees to the right. So x minus 90 plus 2. Question 47, determine two equations for a sinusoidal wave that has a max at 0.5 vertical shift. Okay, so I'm going to sketch this out. Max is over there at 0.5. Vertical shift is the equation of axis, which is 2 down. So my axis is at -2. This means I can tell my amplitude here is 7 because it's that distance, which means my minimum is at -9. Sketch this out really quickly. Period is 120. So I know that my equation of axis is y equals -2. It's just my vertical shift. My amplitude, I told you how to figure that out from the graph. It's just the distance from here to here, which is 7. My period is 120, which means that my k is 360 over 120, which is 3. So let's start by writing, I'll do the cosine equation for this one first because it starts at the max. Pretty easy to find that. There's no phase shift. So y equals 7 cos 3x minus 2. That's my cosine equation for this one. My sine equation for this one is going to have a phase shift. That's the point right there where the sine equation starts. So 7 sine 3x. And then to find this point, I know the whole thing is 120, which means that the middle here is 60, which means that each quarter is 30. And it means that, oops, I labeled that wrong. That's the 30 right there. You know, my graph is a bit off. Means that point there is 90. So my phase shift for this one is 90 degrees to the right. Okay, so X is the number of hours in terms of midnight. So over here, basically we're at midnight. And then in the daily period, the highest tide is traditionally at 8 a.m. reaching 5.2 meters, and the lowest tide is at 8 p.m. reaching 0.6 meters. Draw a sketch and then find all these key features. And then we have to write a function. So we want to make sure that we can fit 24 hours in this scale. So I think I'll go by twos. Twos would be best. 2, 4, 6, 8, 10. Yeah. I'm going to go each block by twos on the x-axis. So my first point is at 8 a.m. and it reaches a height of 5.2 for my y's. I'm just going to go by ones. I don't need too much space on the y's. So 8 and 5.2. And then 8 p.m. So 8 p.m. is, so noon is 12 hours after midnight, and then plus 8, that's going to be at 20. Because 8 p.m. is 20 hours into the day. So at 20 hours or 8 p.m., it's only 0.6 meters. And before I sketch this out, I'm going to find all my key stuff first. My period is obviously 24 hours because it's in a day. My amplitude is my max, which is 5.2 minus my min divided by 2. If I do this in my calculator, you get an amplitude of 2.3 meters. My equation of axis is max plus min over 2, which is 2.9 meters, and I'll actually just draw this on here to make my sketch a bit easier to do. I know between 8 and 20, I'll just do the midpoint of those two just to find my axis point. That's exactly at 14. So that's the axis point right over there. And I know that my period divided by 4 is 24 divided by 4, which is 6. So the distance between this and this is 6, this and this is 6. So my next axis point here is actually at 2. And on this side, my next one will be at 26 because I'm just adding and subtracting 6. So now I can sketch my graph out. That's one complete cycle there. I'll extend it and put an arrow on this side. On this side, I'll just hit the y-intercept. We don't know the exact point. It's not super important. And then this question is talking about a coast graph. So I know that a coast graph starts at the max. So the phase shift is just 8 to the right. Basically 8 hours to the right. So now I can just write my equation based on all of that I have over there. It's pretty easy. Y equals, my amplitude is 2.3 cos, my k value, k equals 360 divided by p, which is 24. Do this in my calculator and get 15. So 15 x minus phase shift is 8. And then equation of axis is 2.9, basically the same as the vertical shift. Okay, question number 49. Windmill is 40 meters tall, has 3 blades measuring 10 meters. Graph the height of the tip of the blade that starts at the bottom of the windmill and rotates around counterclockwise. Graph 2 rotations. Okay, so what I understand from this question, I'm going to go up by tens over here. So the equation of axis is going to be y equals 40 because that's how tall the windmill is and that's where the center of the axle will be. The blades are each 10 meters, so that's the distance of the blades. So if I add, basically my amplitude is 10, my equation of axis is 40, so my max will be at 50, my min will be at 30. We have to graph the blade that starts at the bottom of the windmill, so our starting point is at our minimum here, which is at 30. And it does not give us a period of this function. So technically we can't really do this question. I'm just going to graph something random. But this question is actually missing information. I'm just going to graph 2 random cycles and we'll just move on to the next question. I'm not even going to find the sine and cosine function because actually I'm not going to do it. They don't give us any x values. So technically this question is missing information, but if we had x values, we would be able to do it. Okay, next chapter is discrete functions. The state of the following series is arithmetic or geometric. This one is definitely arithmetic because it's going up by 6 every time. right? The explicit formula. So Tn equals a plus n minus 1 d. Tn equals, my first term is 9. My common difference, so I'm from 9 to 15, I'm going up by 6, and then I just have to simplify this. I'll multiply the 6 into the bracket, and then I'll combine like terms. So that's my formula right there. And then to find T10, I'm just subbing in 10 for my n, and I'll just get 63. Second one over here, this is definitely geometric because I'm multiplying by -2 every time. So Tn equals a r n minus 1. My a is my first term, which is -1, so I don't need to even write the 1. My r is a common ratio. To get from -1 to 2, I have to multiply by -2. So that's my formula right there. And then T10 is just -2, n minus 1, which is -2 to the power of 9. And then I'll just put this in my calculator. Make sure you type it exactly the same. Don't distribute the negative into the bracket. That's not allowed. Just get 512. Oh, 5 more questions left. Okay, I'm going to extend this. I do have to leave, but I'm just going to try and finish all these 5 questions in the next 15 minutes. So an arithmetic series of 50 terms, 17th term is 53 and 28th term is 86. Determine A, D, and S of 50. So when you get a question like this, we're solving with substitution. I'm starting by subbing in my regular arithmetic formula. So let's start by putting the first one over here. 17th term is 53. So 53 equals a plus 17 minus 1. I'm just going to do it quickly. It's 16. I'm not going to show all the steps these last few questions just because I'm running out of time. So that's my first formula over there. Oops, 16. And then my second formula, 86 equals a plus n minus 1. So n is 28, so 28 minus 1 is 27d. Then you can either solve with substitution or elimination. I'm going to do substitution because for geometric, you can only do substitution. So I'll isolate my a here. I'll substitute my a in here. I'll combine my like terms. I'll subtract 53 on the other side. And then I'll divide by 11. So d equals 3. And then I'll just sub in my d over here to find my a. And a equals 5. And then I have to find S50. So S50 equals n over 2 times a plus, I gotta look up this formula. I don't have it memorized. Sum of arithmetic series 2a plus n minus 1d. Okay, so 2a plus n minus 1, 50 minus 1 is 49, and my d is just 3. 50 divided by 2 is 25, and then I'll just put all of that in my calculator. 157. The final answer is 3925. Fifth term of a geometric series is 4, 5. Sixth term is 1, 2, 1, 5. Find the sum of the first 9 terms. So since it's the fifth and sixth term, I don't need to do substitution here. To find the common ratio, I can just do 1215 divided by 405, which is 3. Then I can just put this in my main equation to find my a value. So I'm going to do Tn equals a r n minus 1 to find the a value. I'm going to use the fifth term here. So 405 equals a. My r I found as 3, and then this is the fifth term, so 5 minus 1 is 4. 3 to the power of 4 is 81. And then if I divide by 81, I'll just get my a as 5. I just divided by 81 on both sides. So now I want to find S9. So I'm using my geometric formula, the sum of the geometric series. That's just a r to the n minus 1 over r minus 1, which is 5, 3 to the power of 9 minus 1 over 3 minus 1, which is 5 times something over 2. 3 to the power 9 minus 1 is 19682. And then if I do this entire calculation in my calculator, I just end up with 49205. Do 53 next. Find the sum of the following series. Okay, so I think I'm gonna end with this one. I don't know. Okay, let's see. Actually, you know what? I'll finish it. Why not? Just probably skip. Yeah, I'll delay my next meeting just a bit. So this over here, we can tell is an arithmetic series. We need to find first term. Actually, no, I'm gonna end it. I'm running too late. I'm already late, so I'm gonna end it right there. I'm not gonna be able to finish the last 4 questions of this review, but I will attach it as a part 2. Won't be really long. It's just got a couple of series and sequence and Pascal triangle questions, but I'm just going to end with this one for this video. So if you made it to the end of this video, you found this content helpful, please hit that like and subscribe button. And if you found any mistakes, please make sure to put it in the chat and I will double check them. Thank you for watching and have a wonderful day and good luck for your final exam.